Today I want to walk through an implementation of stats and modifiers using the broker chain pattern. This is a variation on the classic chain of responsibility pattern, but instead of walking through a linear chain of objects, a broker or mediator handles all the requests for information. So the broker chain is really a combination of the chain of responsibility and mediator patterns. In our example today, we'll have a stats mediator that makes sure that all the modifiers that do apply to a given stat are calculated. It can be used for pickups, equipment, environment buffs, or anything else you can imagine. Let's take a look. Let's have a quick look at what we're actually shooting for here. What I want to do is start applying modifiers to this character's stats. The character only has two stats, attack and defense, and they're going to show up in the top right corner here, along with some little buff icons as I get different buffs and debuffs. They'll just kind of stack up like you'd seen in an MMO. Now, let's actually just hit play here and I'll show you what'll happen. So this first one is a defense buff. You can see my defense just went up a few points and I have a little icon. Then I've got one that raises my attack. And then this one here is actually a debuff on attack. So it went down, and now without the first buff, it's down to 0. Eventually everything comes back to normal when they all wear off, and that's it. Let's have a quick look at a diagram. So at the topmost level is going to be a class that's going to contain our stats. It's more like an interface into the world of our stats. It'll have a reference to our base stats, but it'll also have a reference to the stats mediator. It's going to be the broker in this pattern. So our stats class is going to be able to make requests to the stats mediator and say, here's my base value, calculate whatever modifiers apply to this and give me back the actual result. This way, anytime we're trying to access a stat from the stats class, we're going to get the calculated value with all the applied modifiers. Now, when we're adding a modifier, so we run into an object in the game or we equip a magic item, we're going to add that onto the chain of modifiers inside the mediator. We're going to need some base stats to work with, so I'm going to create a scriptable object here and we'll keep it super simple for this demo, just two stats, attack and defense. Let's add a way to make one of these in Unity and then we'll move on. That's all we have to do here. Let's start with the stats class. For ease of use, I'm going to define all the types of stats that I have in an enum. And now our stats class itself will need a reference to those base stats. We're going to keep this private because I want the only way to be able to read a stat will be through a public property. And when you go to read the public property, I want it to return the base value plus every modifier that's been applied to that particular stat. So I'll expose attack and defense in the same way. Once we're finished implementing the pattern, we can come back and fill these out. So for the next part of the pattern, we're going to implement a mediator that's going to sit in between the stats class and all of the stat modifiers. Now, in the spirit of the original Gang of 4 implementation of chain of responsibility, we can implement this as a linked list, but it can really be any type of data structure that you want that you can iterate over. In a broker chain, it's not strictly necessary to keep all of your modifiers in one list where you can iterate over all of them, but it is extremely convenient because all of them are going to have timers or perhaps other logic that needs to be updated every frame, so it's good to have a reference point for all of them. In a broker chain, we're going to make queries against all of the things in the chain. The query is going to be specific to a type of stat, and it's going to contain a value that gets mutated by everything in the chain as it goes through each of them. Let's add a simple constructor for this, and then we're done with the query. If we come back up to the stats mediator now, we can add an event handler of type query, and we'll just call that queries. You could go with an action here too, but I kind of like the idea of being able to pass in details of the object that initiated the query. Now, whenever we want to know about a specific stats modifiers, we can perform a query. So we'll have a public method here that will just invoke all of the queries that we've stored inside of that queries variable. Every time we add a new modifier, we are also going to register it with the queries. So down here, let's add another public method to add a modifier. It'll take in a modifier and add it into our list. And then we're also going to register the modifier's handle method into our queries. So you can probably see where this is going already. Every time we perform a query that's going to be specific to a type of stat, every single modifier is going to get its handle method called. So let's add a bit of functionality to a stat modifier. I'm just going to collapse up this query class because we're not going to be making any more changes to it. Let's add an abstract method for the handle. Now, handle on an event handler is going to need to accept an object as a sender, but it's also going to accept that query for us. I also want all of my modifiers to be iDisposable, which means they are going to have to implement a dispose method. So let's add that as well. Each stat modifier might need a little bit different handling when we're disposing of them. So instead of having anything concrete in here, let's just create an action and we can invoke that action whenever we're running the dispose. How about before we make this class any bigger than it already is, we move it into its own file. Now, once we've got this over here in a new file, I'm going to continue adding a little bit more to it. I want to be able to mark one of these for removal when it's actually done doing what it was supposed to do. So if it had a timer and the timer's run out, we'll mark it for removal. And when we're kind of done all the operations on a modifier for that frame, we can check all the ones that need to be removed and we'll remove them. So in the dispose method, we'll set marked for removal to be true. Now, almost all stat modifiers in this implementation are going to need a timer. For people new to the channel, countdown timer is a class that we use often, and I'll put a link to that in the description. In the constructor for this class, let's accept a duration for the timer, but let's say if we pass in 0 or -1, it means that this particular modifier is either permanent or it's permanent until we manually remove it. So for example, a potion might last 30 seconds, but if you're equipping the magic sword +1 to attack strength, then you want that to persist for as long as you have the weapon equipped. So assuming we did pass in a positive number for the duration here, we can create a new countdown timer for that duration. And then we can say when the timer stops, let's add an event there just to run the dispose method and get rid of this one. And of course, we also need to start this timer. And with all timers like this, we need to pass it delta time every update. Okay, well that's it for this abstract class. Let's jump back over to the mediator and try and wrap up that class as well. We can add an update method here that will accept delta time and pass that down into all of the different modifiers so that if they have a countdown timer, it continues to update itself. So we'll start with the first node in the modifiers list. As long as it's not null, let's get a reference to the modifier in that node and we'll pass in delta time and then we'll grab the next node in the chain. Once we've gone through and updated all the modifiers, now we might have some that actually are finished and we should remove them. So let's do another pass. Again, let's just grab the first node there and we'll do another while loop. Inside the loop, let's first get a reference to the next node in the chain because we might be removing this one. If this modifier was marked for removal, we need to do two things. We need to remove it from the list and we also need to call its dispose method. Then we can just move on to the next value in the list. We can make this even simpler by hooking into the onDispose method of every single modifier. Instead of removing the modifier from the list down here in our loop, let's actually hook into that onDispose method. We can both remove it from the list and remove the handle method from the queries. Okay, so how can we use all of this in our actual stats class? Well, let's come back here to the public property. Let's start with attack. Let's create a new query for the stat type attack, and we're going to start with that base stats.attack value. Next, the mediator can perform this query, and that'll make sure that every single modifier will have a chance to potentially modify this particular stat. Before we get to the final line here, which will return that value after it's been through all the modifiers. Let's jump down to defense here. I'll let Copilot fill it out because it's going to be basically the exact same thing, but we're going to use a different stat type and a different starting value. Just a few things left to do now. We need a constructor, of course, for this, and that should take in a mediator as well as our base stats. There we go. And let's actually overwrite the toString here just so we can use it for some debugging. We'll just output these two stats, attack and defense. Only one more thing to do before we can start using this, and that is we need some kind of concrete stat modifier we can use. I want to make a simple one that will just do math operations on a stat so it can add a little bit or multiply it by a value. So let's have it know which type of stat it's going to affect, but also have an operation it can perform on that value. Then we need a constructor for this. The constructor will take in the type, duration, and operation, pass the duration down into the base class, and then set that type and operation. Then we can finally implement the handle method here. And what the handle method will do is say, If this stat modifier affects the stat in the query, then all we have to do is run the operation on that value. So that's almost the entire pattern implemented, although we don't have any practical usage yet, and I'm sure that will help with the understanding a lot. So what I want to do next is just implement a pickup system, like imagine you're picking up potions or whatever in the game or some kind of power-ups, and let's see how this actually all plays out together. I'm going to implement pickups using the visitor programming pattern, and I'll actually put a link up here on the screen to that video if you're not familiar with this. But whenever we bump into a pickup on the ground, I want to run a method called apply pickup effect, and that'll actually add the modifier to the player or creature that ran into this pickup. In order to do that, we have to actually visit the player or other entity that bumped into this particular pickup. So we'll add the visit method here. Whenever we visit something, as long as it is an entity, then we will apply the pickup effect to that entity. Then in order to run this visit method, we actually have to have the thing that we bumped into accept the visitor. So let's add an onTriggerEnter. As long as this thing has an iVisitable component, we can ask it to accept this object, this pickup. And then we'll destroy it. Though maybe you want to kick it back into an object pool and spawn it somewhere else. Okay, so that's an abstract pickup. What does a concrete pickup look like? Well, there could be all kinds of pickups. So let's make one that's actually a stat modifying pickup. For this class, we want to be able to define the kind of operation we want to do. So it could be add or multiply. We can add or multiply by negative numbers as well. Then let's expose some fields to the Unity editor so we can make some settings here. And I could also wrap these in some kind of scriptable object if you wanted, but let's just go ahead with a few serialized fields here. We can define the type. We can define the operation to perform. We'll also need to set the value for this operation. And then potentially, if we're going to have a timer, we should set the duration of how long this modifier actually lasts. Then we can override this apply pickup effect method. And in here, we could have a switch. The switch will assign a modifier into a variable that we can use in a minute. So we can say if the operator type was add, we'll create a new basic stat modifier with the type, duration, and an add operation. If it was type multiply, we'll do the same thing, but we'll do a multiplication. Any other type of operation will throw an exception. And now, once we're out of this switch statement, we can take this modifier that we've created and we'll add it to our stats mediator. Okay, that's all we have to do with pickups. We also need to do a little bit of work with the entity just to make sure that it can accept visitors and has its own stats and all of that. So let's jump over there. This class here is going to be the base class for all the creatures in my game and the heroes, all the players. They all need some starting base stats, and they all need an instance of the stats class. In our awake method, we can initialize our stats. Remember that the stats class needs a new stats mediator, and it also needs a reference to these base stats. The stats mediator class also needs to receive time.deltaTime every update so that it can update all the modifiers it's keeping track of. Let's pass that in through our update method here in this mono behavior. Then let's not also forget that we need to accept visitors when we're running into pickups. So when we accept a visitor, we're going to run the visitor's visit method on this particular entity. Now, I just want to do one little bit of cleanup, and that's back in the stats modifier class. In the dispose method, we don't actually have to mark this for removal. Instead, what we could do, especially because the mediator is already calling the dispose method, is let's just mark this for removal when the timer stops. And that's it. Let's go have a look at the setup in Unity. Okay, so let's start by having a look at the hero. Now the hero inherits from the entity class, so you can see it's already exposed some base stats here. I've already made them and dragged them in, so I've got a base attack of 10, a base defense of 20. That's it, super simple. And I've set up 3 little buffs. The first one is an attack buff here, and it's this sort of orange orb that spins around. Now, I added some icons and sound effects and stuff just to make it a little bit more apparent what's going on. But this is a type attack that multiplies by 2 and has a duration of 5 seconds. The next one here is a debuff. So it's going to play a slightly different sound, and it has a different color. You can see it's kind of purple. And what this one is going to do is on the attack stat, it's going to add -10 and again last for 5 seconds. And this last one here will affect the other stat, the defense one. It's going to add 14 defense for 5 seconds. And yeah, that's it. I'm just going to move this purple one a little bit because it's right on top of the hero. And then we can try this out. So if I press play, let's come over to the debuff first. You can see that right away it took my attack down to 0. and they all stack up there, and they're going to come off one by one. So that's a little bit fast, but let's, just for an example again of the stacking, let's duplicate the multiplier of the attack buff. So if we first let's hit this defense one, so that goes up by 14. Then you'll see my attack doubled and then doubled again and then went down by 10 points. And as these come off, it'll come back to a normal 10. And that's it. That's one way you can handle stats and modifiers with a broker chain. Just before I say goodbye, I just wanted to show you one more thing, and that is, what would you do if you were equipping an item and you wanted to apply a modifier? Now, this is going to be a very bare bones, extremely naive implementation, just for an example. But let's suppose we have an interface iEquipable that has a method getStatModifier on it. And then let's further suppose that we have a magical sword. We'll call it sword +1. It's going to return a stat modifier that is exactly like you think it would be. It works exactly the same as the pickups. Now, since I don't have an inventory system set up in this demo, let's just have some public methods on the entity to equip or unequip an item. When we equip the item, we need to add the modifier to our stats mediator. Now, Copilot kind of has the right idea, but actually all we need to do when we unequip an item is we need to mark that particular modifier as marked for removal. The mediator will take care of the cleanup. All right, well, if you learned something new today, hit the like button. Don't forget we have a Discord where there's lots of interesting conversations going on all the time. I'll put some boxes up on the screen in case you want to watch anything else from the channel, and I'll see you there.